So, the standard form of conic sections. So all conics have their own standard form. Like, I'm sure you're familiar with the standard form for ellipses or hyperbolas or circles, parabolas. But for all conics, there is a standard form that's just general to all of them. And it's a times x minus h squared plus b x minus h y minus k plus c y minus k squared, and then usually a minus f equals 0, or sometimes they'll bring that to that side and say equals f. So this probably looks like a lot. It might be like, you might think it's the most random thing. How will I ever remember this? But no, it's not. If you see, like, this part is pretty familiar, right? The a times the x minus h squared, this reminds us of a parabola, a vertical parabola. So all of this, we have our h's and our k's. It looks pretty similar to stuff we've seen before. So in this equation, the center, as per usual, is at hk. And so if we were to expand this out, we'd eventually get it into a form. If you can see, the a has an x squared, the b has an xy term, we'd eventually get it to the general form, which is ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. And there are a lot of interesting things you can do with the general form, like identification of conics, like what conic it is, and just a bunch of other really neat things. But the standard form is generally a little bit more confusing, at least just because it looks so intimidating and there's a lot of algebra going on. So I'm going to focus on that for this video, but there will be another one on the general form. So there's a few here. I'll go over some properties of the general form, the standard form. So one of them is that the area of this conic, whatever conic is in this, is going to be represented by 2 pi I over the reciprocal of f times b squared minus 4ac, which I hope you recognize as the discriminant of the quadratic formula. Sometimes, instead of having the I here and then this, because this will always be imaginary, sometimes I've also seen it written as 2 pi over 1 over f square root of 4ac minus b squared, because then you eliminate the imaginary square root, and so you don't need the I at the top. But this is the one on the left is what I usually see, so I'm going to leave it as that. And so another thing you can do is, with this form, it's really easy to tell the center, right? We have h and we have k. So when you have something in general form, which is the form I just put up here earlier, if you can factor it into this form, it makes it so nice because it's so easy to see the center. And that's not a problem usually. Like, let's say we had an ellipse, just a normal ellipse with no xy term, then it would be fine. We just do our normal way of putting the ellipse into standard form to find the center. But we can't always do that. Like, if we had, like, let's say 2x squared plus 4x plus 5xy plus 6y squared plus, 8y equals 7, that's a lot harder to find the center or just factor in general, just because we have this xy term here, and that adds rotation, and now we really don't know what's going on. So, yes, we could rotate this. We could rotate these axes and get it back to a horizontal or vertical ellipse, and then rotate it back, but that's just really complicated, and I always feel like if you can factor, it's so much easier to go that route. So I will show you what I mean by that. So let's look at these questions right here. These are from the 2018 Nationals Mu Alpha Theta test. Okay, from the analytic geometry test, which is some test, let me tell you. Okay, so question 10 says to find the center of that conic. So what we're going to do is we're going to take the standard form and we're going to expand it out. Yes, I know, I recognize that sounds super, super painful, but just bear with me here. We want to see what we can do with this. So, and besides, you're not the one expanding it out, I am. Well, I would recommend that you do it as well. But I'm going to do this right here. And, for people watching this in the future, I probably will not speed this up and edit it because I'm lazy. Watch me mess up while factoring this. At least if I do, it'll be a funny laugh. Yeah, words. I wish I had something interesting to say while I do this. And the funniest part is I'm focusing so much, and I probably am still going to mess up. Minus f equals 0. Wow, look at all of that expanded out. And just hope I did it correctly. Now we're going to do something that we very commonly do. First, let me expand this out right here so we can get minus, oh dear, plus bxy minus bhy plus bhx minus bxk. Okay. That's done. Now we're going to do some coefficient matching. So I like to start with the, the xy's don't go away. The a is a constant, the b is a constant, the c is a constant. But the xy's are going to stay. So if you see something that's like a and then x squared, that's going to match up with the x squared terms at the top. So that's easy to match. But if you see something like a, h squared, remember a and h are both numbers, they're not variables, so that's going to be a constant. So let's coefficient match the x squared first because that's easy. So we have that there's one x squared term up here, and that's 5x squared. So, we have that ax squared equals 5x squared, so a equals 5. Simple enough. That's done. What else do we have? Well, we have the cy squared, and that cy squared, there's only one y squared term at the top, has to equal y squared. So c, I guess, c must equal 1, yeah, just 1. So c equals 1, which we can check off. And we only have one xy term, which is important, right? So we have to match that up. And now we know what b is. We know that bxy is going to equal, where's the xy term? Oh, 2xy. So b is equal to 2. And now we have, a, b, and c. So all we have to do is solve for h and k, and bam, that's our center. So let's see. What do we have up here that we can solve for? Let's just try to make these into separate equations. And if you realize, yes, that's probably helpful. I would just expand the entire thing out. But if we wanted to find a, b, and c, we really didn't need to expand the entire thing out. We could have just said a squared is equal to the x term, bxy is equal to the xy term, and cy squared is equal to the y term. But now that we have this, we can set this up for our system of equations. And yeah, it's going to be a system. So we have here, let's try to set everything we can equal to the x term, right? So we have negative 2xh, so let's do the x term here, negative 2ah, because we're solving for h, plus, that doesn't have an x term, we already did the xy, that doesn't have an x term, b, so actually it's going to be minus b, there's the x term, k, and then what? That's a y term, a y, that's a constant. So that's going to equal, what is our x term equal to? 4. Okay, and now we have the y. So that's x, that's just numbers, that's xy. Here we go. Negative bhy, and then that's an x, y squared, that's just a y term, minus 2 CYK, that is going to equal our y term, which is -4. So let's convert this into actual numbers now so we don't have a bunch of letters. So we have that -2 times a, which is 5. So -10h minus b times k. Oh, bk. Yeah, okay, we're good. bk. So -2k is going to equal 4. And then we have that -bhy. So, oops, I don't have to write the y here because this is -4y, right? So we can just divide all the sides by y because that's what we're coefficient matching, right? -4. So we have -bh, which is -2 times h, minus 2ck, so minus 2 times c, which is 1, times k, which we don't know, 2k, equals -4. Wow, this is crazy. We have the same coefficient for k in both of these. So what can we do? We can just subtract these equations, and we get that -8h equals 8. So h has to equal -1. Now we just plug this into here, and we get -2 times -1 minus 2k equals -4. So -2k equals -2. Oops, I can't subtract, apparently, because this is just 2. Equals -6, so k equals 3. And now our center is -1, 3. Okay, so, that was a process, but it worked, and it gets, easier and faster. The more you do it, the more you coefficient match. I just want to clarify, the way I was able to do this is because I just found all the ones with an x term, and I was like, -2ahx minus bkx equals 4x, right? Because the x stays. There's no variable, there's no set number for x, it's just a variable. So then we can divide all the sides by x. And now we have a system, and then do the same thing for all the y terms. That's a very common technique. It's called coefficient matching. So that's how we got our center, -1, 3. And just for satisfaction, I can circle that on the little thing there, and just wish that I'd gotten that on the actual test, but I didn't because I didn't know how to do this. But now you do. Okay, so now we need to determine the area of the ellipse, right? And I gave you the formula for that, right? It's 2 pi I over 1 over f times the square root of b squared minus 4ac. And luckily for us, we have most of these. We just need to solve for f. So to solve for x, we need to get all of our constants together. So we have a, and remember, those are just anything without an x or y term because f is our constant. So if ah squared, that has an x, that is a y, bhk, bhk has no x or y, and that has an x, that is a y, that has a y. That should have a c, k squared. So I was right. I did mess up while I was, expanding it out, but that's okay. We got it. Plus, I haven't done this in a while. Plus, not cy, ck squared minus f. And this is going to be equal to whatever our constant term in this equation is. And as you can see up here, maybe I should do it. Maybe I should highlight it. It's in blue. Up here, that constant term is -2. So this is going to be equal to -2. And so luckily for us, we already know what a, b, h, k, and c are. So we can just say 5 times -1 squared plus 2 times -1 times 3 plus 1 times 3 squared minus f equals -2. So we get 5 minus 6 plus 9 minus f equals -2. What is this? 8 minus f equals -2. Oops, -12. -2. So f equals 10. Okay, awesome. Now we can plug this into our equation up here. So we get that the area is equal to 2 pi I over 1 over 10 times b squared. So 2 squared minus 4 times 5 times 1. And here is what I was talking about, because when we use this, we get 10 times 2 pi I, and on the bottom, we get 4 minus 20, so this is the square root of negative 16, and we're going to have to use the I, this is just, negative 16 is just I square root 16, so this becomes 20 pi I, and that's why I said you might want to do 4ac minus b squared, so then you don't have to deal with the i's. But personally, I don't think it's a huge deal over 4i. The i's cancel out, the 20 pi over 4 just becomes 5 pi. And so the area of this conic section is 5 pi. Hopefully you thought this was, helpful. I certainly think that this is a good thing to know. You will probably see a lot of questions on it. And it's not that scary. It looks really scary, but it's really not. It's just algebra. That's all it is.